Have you ever found yourself staring at that progress bar, just wondering, why is my COMSOL simulation so slow? Well, you're not alone, and the answer, almost every single time, comes down to hardware. So today, we are going to dive in and figure out how to build the perfect machine to get your simulations running the way they should, smoothly.
Oh, we've all been there, right? You've set up your physics, you've dialed in your mesh, you hit compute, and for a second, everything feels great. And then you hear it. The fans just scream to life and your entire machine grinds to a halt. It is such a universal frustration, but here's the good news, it's a solvable one. And that is the big question we're tackling today. We're going to cut right through the noise, all the technical jargon, and focus on the hardware that gives you the biggest bang for your buck. The goal? Less time waiting and more time actually analyzing your amazing results.
Now, when we talk about performance, not all computer parts are created equal. It is so easy to get lost in spec sheets and marketing, but the reality is, for COMSOL, there are only a few key components that are truly critical for a snappy experience.
And here they are. I want you to remember these three: CPU, RAM, and storage. This is the big three: your central processing unit, your memory, and your hard drive. I'm telling you, if you get these three components right, you are 90% of the way to a fantastic COMSOL machine. Seriously, almost everything else is secondary.
And this is where it gets really interesting. Just look at the huge gap between the official minimum requirements and what you actually need for a real project. I mean, look at that RAM difference. And trust me, we are going to come back to that one in a big way. This table right here gives us the perfect roadmap for what really matters.
All right, so let's get into the nitty-gritty. We're going to break down each of those key components one by one so you know exactly what to look for, whether you're building a new machine from scratch or just looking to upgrade your current one.
Okay, first up, the CPU. Think of this as the engine of your simulation. Now, you might think more cores is always better, and while that helps with certain things like parametric sweeps, for the actual number crunching part of solving, COMSOL absolutely loves a high clock speed. So here's the big takeaway. Raw speed often beats the raw number of cores.
So what does that look like in the real world? Well, for most of you, a modern Intel Core i7 or i9 or an AMD Ryzen 7 or 9 is going to be fantastic. Now, if you're running absolutely massive, industrial-scale simulations, that's when it makes sense to step up to the big guns like a Threadripper or a Xeon chip.
Okay, let's talk about what is probably the single biggest bottleneck for almost every COMSOL user out there: RAM. According to the official documentation, the absolute bare minimum amount of RAM you need is, well, get ready for this:
4 gigabytes. Yep, you heard that right. Just 4. It seems kind of unbelievable, doesn't it?
And that's because for any real work, it is unbelievable. In the real world, 4 gigabytes is basically just enough to double-click the icon and launch the application. The moment you try to load or mesh even a simple model, you're going to hit a wall hard. So this chart right here, this is the reality. For basic 2D models, you really should be looking at 16, maybe 32 gigabytes. For your standard 3D multi-physics work, 64 gigabytes is the sweet spot. And for those heavy-duty industrial simulations, you're going to want 128 gigs, maybe even more. If you've been getting those dreaded out-of-memory arrows, I can almost guarantee you this is why.
The third piece of our performance puzzle is storage. You see, COMSOL generates enormous temporary files while it's solving. And if it's trying to write those files to a slow, old-school hard drive, it can bring your whole system to a grinding halt. A fast NVMe solid-state drive, on the other hand, makes a massive difference, especially during meshing and solving. So the key takeaway on storage is this: your primary drive, the one where your operating system and COMSOL are installed, should be, at a minimum, a 1 terabyte NVMe SSD. This makes sure you've got plenty of high-speed space for both the software itself and all those huge temporary files it creates.
So what about the graphics card, the GPU? This is an interesting one. While it isn't a core requirement for most of the software to just run, a supported NVIDIA GPU can act like a powerful coprocessor. It can give you a really significant speed boost, but only for very specific and very demanding mathematical jobs.
Now, to take advantage of this boost, you need a specific kind of card. The magic phrase here is an NVIDIA GPU with a compute capability of 6.0 or higher. This feature is what allows COMSOL to offload some of the heavy lifting from the direct solver calculations to the GPU, which in turn frees up your CPU to work on other things.
Okay, so we've covered the individual components. Now, let's put it all together.
We're going to look at 3 different tailored setups, so you can find a build that perfectly matches what you do and, of course, your budget.
First up, let's call this the student or beginner build. This is a super practical, cost-effective setup that's absolutely perfect for coursework or learning the ropes. We're talking a modern Intel i5 or a Ryzen 5 CPU, a solid 16 gigabytes of RAM, and at least a 512 gigabyte SSD. This will handle your basic 2D and 3D models with no problem at all.
Next, we've got the workhorse build for most professionals. This, right here, is the sweet spot. You've got a powerful i7 or Ryzen 9 processor, a generous 64 gigs of that all-important RAM, a speedy 1TB NVMe SSD, and a capable NVIDIA RTX series graphics card. This machine is built to handle daily, mid to large-scale simulations with ease.
And finally, for the heavy hitters, we have the top-tier workstation. Here, we're talking about high core count CPUs like a Threadripper, a massive 128 gigabytes of RAM or even more, and a professional-grade NVIDIA GPU. This is the machine you need when you're running the most demanding industrial models, huge parametric studies, and really complex simulations.
Awesome. So before we wrap this up, let's just go over a quick checklist. Think of these as simple habits, some pro tips you can start using right now to squeeze every last drop of performance out of any machine, whether it's the one you have now or a brand new build.
These are some really easy wins. First, close other programs. Seriously, free up that precious RAM. Make sure COMSOL is actually using your fast SSD for its temporary files. Be smart about your meshing. An overly dense mesh is a classic performance killer. And finally, keep an eye on your memory usage while you work, and always keep your GPU drivers up to date.
So that really brings us to the final question, the one I want you to ask yourself. Take a good, honest look at your own machine. After everything we've talked about today, is your computer a bottleneck that's holding you back? Or is it the powerful launchpad you need for your next great simulation?